All right, we are ready to do our physics review. And so we're going to start this. Good afternoon, everybody. Or good morning, everybody. Anyway, here's our physics review. Okay, the first part was just terms. And an ampere, I'll just read through them, check your terms. They don't have to be word for word like this, just as long as you know them. An ampere is a unit of current, 1 coulomb per second, how fast it's flowing. Coulombs per second, that's a rate of speed, which is what ampere is. Circuit is a closed path of electrical current. Closed path is an important part of that. Circuit breaker turns off when the current is too great. We're going to talk about that more when we talk about concepts. There's your definition. It's a switch. Current is a continuous flow of charge, or current electricity refers to continuous flow of charge. Remember, static electricity, you may get flow, but it's not continuous flow. Electrodynamics causes and effects of current electricity. Dynamics has to do with energy or power or movement. A fuse breaks when current is too great. So you have to replace a fuse. You can flip a circuit breaker, but you have to replace a fuse. An ohm is a unit of resistance, 1 volt per amp. How much power it takes to create a certain amount of current. Parallel, more than one path for the current. So if you have a parallel system, the current can flow in different directions. Potential difference is the pressure on electrons to move. This is the energy or the force, but think of it as potential, the energy of position or condition. That idea is there. It's not exactly potential, it's a technical difference, but it's very similar. Resistance, to get resistance, you take resistivity and multiply it times the geometry. And we did length over area. There are other geometries, I believe, but it is resistance times geometry. Resistivity times geometry, excuse me. Resistors, the number of things you can say about resistors. One of the things it does is convert electrical energy to thermal energy, because when electrical energy goes into a resistor, it loses energy, and that energy is converted generally to heat. We did talk about that. I remember talking about that. Series, only one path for the current. The current only has one path that it can go through. Everything's in a straight line. The volt is the unit of potential, as 1 joule per coulomb, how much energy there is per unit of charge. And then watt is a unit of power, and it's still 1 joule per second, just like it's always been. All right, concepts. The first question, I don't have the questions in front of me. Oh well. The first question had to do with how fast particles and electrical impulses move. The particles, the electrons, move very slowly. Okay, very slowly, but millimeters per second. They're not moving very fast. The impulse, however, can move very fast, near the speed of light. Remember, if you're thinking about dominoes falling over, the dominoes don't move very fast, but the effect, the fall can move very rapidly and very far, and that's the idea here. Okay, in a current, they ask us about series and parallel circuits. Current is the same in a series, because the current is how many electrons are moving per second. And if it's a series circuit, they have to go through all of the parts of that series because there's only one path. In a parallel circuit, there are multiple paths, and so the current chain is different. It splits up among the various paths. On the other hand, number 3 asks us about voltage. Voltage drop is the same in a parallel circuit because it's going from point A to point B, just 2 different paths to get there. When it goes from point A to point B, that's like falling down stairs. It has to go that from the top to the bottom. Whether the stairs are steep or shallow doesn't matter. It has to be the same. However, in a series circuit, they're completely independent of each other. It's like a series of steps. They don't have to be the same height at all. So the voltage drop's the same in a parallel, but not in a series. So keep those two separated. Make sure you're clear in your mind which is which. And hopefully I try to explain why so it makes a little more sense. This one, I don't think we actually talked about this in the lecture, but it's important. Okay, if current in a circuit gets too high, it can cause a fire. Okay, if your current gets out of control, you can actually start wires on fire. You can overwhelm it. I will just tell you a couple of stories in this section, just because I didn't get a chance to talk to in class. When I was in college, we did I had an electronics lab, and we did all kinds of stuff. And the one we were making a diamond shape. There's actually something similar to it in the homework that I didn't have you do, number 52 or 3, whatever, the last one in the problems. Anyway, it's a diamond shape of resistors. and you put these resistors in this interesting shape, and I don't remember now what it had to do with. All I remember is that we put it together. I'm pretty sure that was the one that we did, and we made a mistake. My lab partner and I made a mistake, and we burned all 4 resistors, and it was like poof, and there's smoke curling up from the resistors, and they stunk. It stank. It was bad. The resistors are bad to blow. I was told that if you put enough voltage across a small enough resistor, you can catch it on fire in the lab. I never did that. Didn't do what we did on purpose. That was an accident. But I was told that you can actually do that. So if your current's too high, you can cause a fire. A fuse is designed to break if the current's too high. A fuse has a little metal bridge, and it's very thin, and it actually narrows. And if you get too much current across it, it burns that little bridge. And when it burns that little bridge, that's like a switch, except it's a permanent one. It turns off and it stays off. Okay, so a fuse is I don't know if you guys have even seen fuses. They were round. They have they screwed into a fuse box. A breaker, I know you guys have seen because you guys pop them whenever you do hot lunch. A breaker is a switch. Not every time you do hot lunch. Sometimes when you do hot lunch. A breaker is a switch that will automatically turn off if the current is too high. So it doesn't break. It just pops, and then you can pop it back into place and start it up again. Now you're supposed to remove whatever it is that's that's putting too much current through your system before you turn it back on. Bypassing them is a bad idea, and I had an uncle. My dad did some electrical work. My grandpa did some electrical work, although not my dad's dad. My mom's dad and my dad both did some electrical work. And my uncle was a fruit farmer, but he had an old farmhouse. And he had taken, and I can't remember what kind of coins they were, probably pennies, because I think copper conducts electricity better than the others do. And he would you would screw a fuse into a socket, like you would screw a light bulb in, only it was a fuse. And my uncle would put a penny behind the fuse and then screw the fuse in. And that way the current would flow through the penny and the fuse wouldn't pop. Well, the fuse was popped. But when you put a penny in, then it would flow straight through. That's dangerous because then if there's too much current, your house catches on fire. It's supposed to, if it gets dangerous, pop the fuse, burn out the fuse, or pop the switch. But if you put a copper coin in, then if you put a copper coin in, it won't pop at all or won't break at all, and you just keep flowing current. And if it's too high, it will burn up. And I did misspell the word height. I may correct that, though, before you see it. Okay, let's look at the math. The resistance of this object, resistance is rho times length divided by area. So we put in the resistivity, put in the length, divide it by the area, and we get 1.15 ohms. There you are. All there is to it. This is a lot of plug and chug. It's just a matter of knowing what to plug, okay? Number 2. Okay, so this is parallel resistors, a 3, a 5, and an 8 in parallel. So 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. So 1/3 plus 1/5 plus 1/8 equals 0.6583. I did that on my calculator. I cheated. And if you take the reciprocal of that, you get 1.51 ohms. Number 3, this is a series of 3 resistors. So you just add them together. 3 plus 5 plus 8 is 16. Okay? So the series is fairly straightforward. Once again, this is all plug and chug. All right, then they said if those 3 resistors, the 1.15 and the 1.51 and the 16 are all in series, then what is the total resistance? And of course, it would be 18.66 ohms. All right. And then they said if the voltage in the system is 12 volts, what's the current? Well, go back to Ohm's law, V equals IR, or I equals V over R. So 12 divided by 18.66 gives us a 0.65 amp current. And that's the review. The only thing I'm going to mention to you is do look over your homework also with all of the pictures. You might want to be able to do that. Test really isn't that long. It actually got a fair amount of math. It has a few terms and concepts, but it's really not that long of a test. And if I'm remembering my lesson plans correctly, you're going to be watching a lab on Monday and then taking the test on Tuesday, and then we have spring break. So that's where we are. All right. Well, I hope everything went smoothly for you. Text me and tell me if you're having any questions or any problems with this. And do text me and tell me how you. When you text, go ahead and text me, and let me know whether you're having any issues with the review. If you're not having any problems, say so, and if you're having any issues, say so as well. And that way, I'll know that you've done the review and that you're figuring it out and that you're ready for the test, or not ready. Maybe not ready for it, as in you need to study, but that you're going to be ready. You're going to have no problem getting ready. All right, have a good day. We'll see you later.